Let's look at long-running business processes. In our solution that I'm demonstrating today, I have two different types of processes. One is short processes that manages every state in my solution. If you remember correctly, we had an order that had certain life cycle milestones that it needs to go through for completion of the entire order. So you can see that I have a number of processes that I've defined. All of them looks more or less like this, where I initiate the data, I get the case references, and I put out a message to a user to perform an action. In this case, need to accept the order or decline the order. I also use timer events or escalations that will allow me to make sure that that activity happens in a certain amount of time. And then at the end of the day, I have a finalized state sub-process, which is a service process that will change the state from accepted, from submitted to accepted if that is the case. I also have a different type of process where I manage my long-running processes from the master process perspective. So this process doesn't look like much. I will go into greater detail on this process and how it works. By creating smaller reusable processes, it will allow people over time to build processes from other small discrete units that can perform action. In our case, this is an implementation where I execute all the sub-process based on the state of the case. They are discrete, they accept an input parameter of a order ID in this case, and from the order ID I can get to all the other cases that it is linked to, for instance, the provider, the notes, and so forth. You will also see that this process is called from an interface which we'll go through in more detail at a later stage, is the ability to expose a process with a certain template. In our case, the interface is just a template that says that this process is triggered by inputting one parameter called a order ID in this case. I've done the same for all the other lifecycle processes that I have. You can see that they are all called from an interface, and there you can see the actual interface process as well. By creating smaller discrete units, it will, in the long run, make it easier to test, as well as speed up your development of your solution. Let's look at this business process that is the master process for my solution. So you can see we have one main flow in our process. Then we have a ad hoc sub-process which manages each of the states as the state changes. I have a global catch cancel event, which means is that in this case a provider or a doctor can at any time cancel the order by triggering an event, and we'll talk about those a little bit more detail. And I have a catch order reference change event. What happens is if a case is saved in another process, it actually triggers an event, which is a data change event. And this event actually listens to those changes that occur. So what would happen is if one of these sub-processes actually changes data or the state of a case, this event is going to listen to that. It is going to update the local case data so that this process knows what the data is that's in that actual case. If the state has changed, in fact, it will find the location of the new state sub-process and will actually trigger an event that says the state has changed, which will make this ad hoc sub-process to trigger the new state action. The cancel event, we can see that we have a global catch, and then we have a local throw. Business process modeling notation says that you cannot throw a local event from a global event. So what I needed to do is when I actually hear or detect an event of a cancellation, which is a global event, you can see down there, I can see the global event from the signal that I listen to, I will then trigger this local event, and if I click on that, you can see it's linked to that cancel order. So if this is triggered, it's going to get here and it's going to cancel the event, which will terminate the entire process for us. Okay, let's look at how I've implemented my master process or my case management style processes. First of all, I have a place, business service that creates cases. In this case, what happens is I define a sub-process for each of these milestones or states that we have in our engine. So we can see accepted is managed by a process that is in this location, and the process is called accepted, and the same for each of these. Okay, so first of all, I define my location. Next thing I do is to define an order of execution. So I have defined a set of rules that says when the process is created, it goes to submitted. In the submitted sub-process, if the user selects accepted, the new state will be accepted. And then from accepted, if it will then trigger that accepted process, if the user in the sub-process accepted says I'm waiting for a patient, the action is waiting, and then the process waiting for patient is triggered. So this is the order of execution. We can see it follows more or less the order that I have there, but that's just to make it more readable. In reality, this could be very, very different from this process execution. So if I just close this, you will see that this is the interface runtime ID that we use when we trigger a sub-process. So let's go back to my business process. And we look at our initial process execution. So as soon as a process comes in, what happens is I pass in the actual current state to a sub-process, and the output of that sub-process is the location, which is really the location that I just showed you in my runtime environment. So when I trigger that process, we can see it's triggered with a runtime ID. So you'll see the output of that process goes into my runtime ID. So that's what triggers that process itself. That script over there does some logging, and it actually gets the order data from the actual order ID to populate the local data for this process. Just looking at this ad hoc sub-process as well, we can see that I map in just the order ID. Because I can get all the case data from the order ID, that's the only field that I pass in. You can theoretically pass in many different types of fields, but I find that it's easier if I just work with one ID for all my sub-processes, because you can get to all the data from the one ID. If I look at my ad hoc configuration, we can see that this process is going to be executed or triggered when the state change data field is set to true. You can also see that this process is going to start listening for events after the find state location and inner data processor. So there's my find state location and inner data process. So this will automatically be triggered based on these configuration items. That's why it's called ad hoc, because it can be called ad hoc based on a certain set of data. Okay, looking at my sub-process again, we can see, interestingly, that I also have just an order ID that comes in. So from my order ID, I initiate some data, which in this case, I set the correlation field that listens to events to order ID, and I set a parameter for the participant who's going to perform that action. I have a timer event that listens to an SLA. In my case, it's 1 month, when it will then trigger that email message saying that, listen, you have to perform this work item if you haven't done that. That event over there you can see as a continuum time task timeout. What that means is that event is going to fire, but it's going to leave that work item in place. We also have the ability to say withdraw on timeout. Say, for instance, we have a work item that escalates and I want to take that work away from that user and send it to another user, I can also do that. That is the execution of my sub-process. One thing worth mentioning is you will see that I really don't keep any data in this local sub-process. What I do keep in this process, for instance, is the references to the data. So when I call this activity or this work item, I pass in the references. And in this case, we trigger the page flow that we talked about earlier. So in the page flow, I will use those references to go and fetch the data. That means that when the user opens up this work item, it will go and fetch the fresh data as it is at the time of opening up. If I had exposed the actual data fields to this activity, the data could have gotten old because this user could have only opened up this work item a week later, which means is that other processes can possibly change their data. So that will ensure the data that the user views is always up to date. Okay, so let's look at the signal event. So I've talked about events in processes. So we looked at that cancel event. We can see that I am referring to a signal project. If I go down to my signal project, you can see I have a cancel lipid panel order signal which passes in the ID. So what you can do is you can actually use another application, an API, or a business service to cancel this order. For instance, a doctor put in an order for a panel test, but the patient says, no, I want to cancel this. I want to go to another doctor, as an example. So that is the Signal project. And I've got another one as well that, that I use for different reasons, but you can see I always just using the actual order ID for the correlation field. In my process, you will see that I have a correlation data field, and I normally use the same name, but just prefix it with a smaller c. And that way I know that it is a correlation field. It's very important to create your own best practices as you learn to use the engine and the design time environment. It speeds up your development substantially in the long run.